Look at this beautiful picture of Lucas Oil. They're going to hold the NCAAs there during a pandemic. That sounds awesome. Whole bunch of people coming into town. Look at that beautiful coal burning power plant off in the left-hand background. Isn't that gorgeous? We've got this really pretty city and it's mostly clean and safe. And we hosted the Super Bowl. And here's this gorgeous power plant right there with carbon dioxide going off into the air and making us all sick. That plant, here it is from the aerial view. And you can see that the train tracks run right by it. Right there is where they burn the coal. There's the big smokestacks that you see. This is a reservoir where they used to hold the giant piles of coal. And the trains would come in and they would come off to this side track and right over here, and they would literally just turn the train cars over. I'll show you that later on what that looks like. And so they would just bring in train load after train load and dump all that coal right there. And then that gets fed up through a big conveyor belt, kind of a ramp that you would see going up, and it gets crushed inside of here, pulverized like they showed in yesterday's video, and then heats up the furnaces, which spins the turbines, which then gets sent right over here to the grid. Yeah, so this plant, its main purpose is to provide energy for the downtown area only. So it's powering places like the Convention Center, Victory Field, Salesforce One building, all that, Lucas Oil. Now, the actual plant that's providing power to most of us right now is called the Harding Street plant, and it's much bigger than the plant that's downtown. And it is on the south side of the city. You can see it from 465, actually, when you're driving by. You can see the smokestacks. And here is a gorgeous view. You can see the power plant, and then off in the distance is the downtown area. And it's really the same idea as the other plant. They've got giant piles of coal that were brought in, a conveyor belt then moves it to the plant where it gets pulverized and then burned. 1,200 megawatts. That's a pretty big power plant. In fact, for many, many years, you can see it, top 12th most polluting plant in the US. Jeez, yay. I have good news about these two plants though, both of them. They are no longer burning coal and haven't been for about 5 years or so now. These plants have now switched over to natural gas. So those big piles of coal that were in these aerial views, look how big the coal pile was at the Harding Street plant, just gigantic. And over here's the furnaces, there's the smokestacks, there's the grid. Okay, so really the same design. Those coal stacks are gone now. That's pretty cool. If you look at an updated aerial view, you won't see the big black area anymore. Most of it's gone. There is a problem that we're going to learn about called coal ash. And coal ash is the remains of the burning and pulverizing process. And we worry about this coal ash, all the leftover dust from it, getting into our water supplies. And look, the White River is right there. That means the water table is high. And so anytime there's rain, coal ash leaches into our aquifers. This is old data, but it really drives home the point of why these two plants switched to natural gas. They were terrible polluters in Marion County. Now, unfortunately, the rest of Indiana is still powered by coal, right? We're the liberal center of the state. We made the push to switch, but the rest of the state's rural and they just want cheap power. So they're still burning coal most of the entire state. So Indiana is still one of the absolute worst coal burning states in the country. And that affects our air quality. Here you can see that through the years, the percentage of pollution in Marion County, by the end here, 88% of it was IPL's fault. It was those two coal power plants. Now, that's not as damning as it looks, because if we interpret the data a different way, we see that actually they were making progress in reducing the amount of pollution. But so was everybody else. So they had the biggest chunk of pollution, but actually, as a power plant, they were improving as well. And now that they've gone to natural gas, it's even better. I love this billboard, right? Air pollution kills 60,000 people a year. How artistic is that? If that doesn't drive home the point of what we're doing to our environment, uh, nothing will. Propaganda, but it's effective in my opinion. Okay, these are some of the problem with coal is that when it combusts, there are byproducts that are damaging to the environment. And the four big ones here that go into the air, well, we have carbon monoxide, which is if you breathe that, it'll kill you. Carbon dioxide, which is a greenhouse gas. And a lot of people don't know this, but obviously it gives off steam as well, which is water vapor. And water vapor is a greenhouse gas. Something is that we think of as inert or harmless is actually part of global warming. We'll learn more about that in the atmosphere chapter. Sulfur dioxide is the acid rain component. We're going to learn by the end of today's lesson, there's a lot of sulfur in the coal that we burn. And then sometimes nitrogen as well, which leads to smog, ozone. Indiana, third in the nation in smog. Really? Like, what about Los Angeles? What about Denver, Colorado? Well, yeah, they're bad, but we are third as a state. Fourth in sulfur dioxide. Our weather patterns kind of push that over onto Ohio and continues to push it east. So you're welcome, Pennsylvania. You're getting all of our acid rain. Well, we get Illinois' acid rain. So carbon dioxide fifth, right? Indiana should not be in the top 10 of any of these. Really, Indiana uses the 9th most energy in the United States per person? What? We're not that big of a state. We're going to learn about something called the Clean Air Act. I'll come back to this later. One of the big things they did in 1990, this goes back a while. In 1990, in the updated Clean Air Act, they introduced something called allowance trading. Let me just be blunt. It's a government loophole for power companies that pollute. Let's say, for example, that you are an industry in Indianapolis, Marion County. Okay, the feds are going to set a limit on how much pollution you can release into the air. I try to remain as politically unbiased as I can, but I tell you, with this unit, it is very clear that left versus right are on completely different paths. Eli Lilly, big major pharmaceutical company. Government says you can release 10 tons of sulfur dioxide this year. Okay, and IPL, you can release 10 tons. That's the limit. So IPL says, well, we're in big trouble because we have 15 tons that are going to need to be released. Well, you're going to have to pay a huge fine then. And Eli Lilly says, well, wait, we're not going to use all 10 of ours. So why don't you buy some credits from us? We'll use 5 of ours and sell you 5 that you can add. So IPL's like, oh, cool. I can now release 15 tons. So allowance trading does not actually lower pollution. It just allows companies to trade them and make money off of it. So some would argue, well, that's capitalism. That's fine. So that's what's going on and has been going on now for 30 years. Instead of actually putting more stringent caps on how we pollute, we've just been passing the pollution around to fit what we were already doing. And you can see with our most recent administration, this is going to be a recurring theme in this whole semester. Pretty much every pollution industrial regulation that was put in place by Obama's administration was rolled back or rescinded under the Trump administration. Trump campaigned on bringing back the coal industry. He was a businessman. He campaigned on the fact that he was going to make these regulations easier for businesses so they could make more profit. And his rationale was that they would then pay their workers more and that the economy would pick up because the businesses don't have as much pressure on them. It's very expensive to trap the pollution and dispose of it properly. So here you can see 2018 EPA announces a plan to roll back mercury limits. That's another pollutant that comes out of coal and it ends up in our water. We'll talk about why mercury is bad in a couple of weeks. Here you can see a picture from Mongolia, right? And remember, in Asia, they were in a in the transitional phase of the demographic transitional model. So they were having huge population growth, huge energy demand, and the cheapest way to meet that is by burning coal. Well, we saw China go through the problems with the air quality, and here in Mongolia, the exact same problem. First semester, I introduced a concept that when we were talking about the atmosphere, that when you have especially a mountain on one side, in the mornings, cold air can get trapped underneath the warm air above. And that's called a temperature inversion. So when everybody drives to work in the morning and all that pollution goes into the air, there's no convection. So it just sits there. And that's, once again, is what a temperature inversion means: cold air under warm air. And the only way to get rid of that morning smog is for the sun to come out and eventually heat all the way up down to the surface. So I thought it was a good idea to bring that term back for review today. Temperature inversion, demographic transition, those are things we learned about first semester. All right, let's get to the heart of what coal actually is. So coal, oil, natural gas, those are all examples of what we call fossil fuels. Fossil fuels are classified as non-renewable, which means we use them faster than the earth can replace them. And my favorite definition for a fossil fuel is that it is stored solar energy. Solar, what? Well, remember that it's decayed plant matter. Where'd the plant get the carbon from? Well, through the process of photosynthesis. What's the carbon cycle? The sun passes the energy into the system, the plant decays, becomes a fossil fuel, and that's where it was supposed to stay forever. But no, humans dug it up and decided to burn it all really fast. That's the root of the problem. Okay, so coal is a rock. And one of the definitions of rocks is that they are mixtures. So not all coal is the same. It can have different mixtures of some of the elements that are in it, carbon and sulfur primarily, mercury as well. It is the most abundant fossil fuel. It's cheap to extract. We're good at it. It's easy to get to. And so it's been the fuel of choice since the beginning of the Industrial Revolution. We also have enough left that if we keep burning it, which would be just terrible for our environment, but if we keep burning it, we got another 250 years worth. So we're not worried about running out of it. So it's a very attractive option. It's also pretty efficient when it comes to heating up the water in a power plant. It's one of the more efficient heat sources. The only one that's probably more efficient than coal is nuclear. So here's the entire process, really. We've got solar energy, which gets stored in living organisms. They decay, they get buried over thousands or millions of years, usually swampy areas. You'll see that in a second. And then humans dig it up the conveyor belt it goes, we pulverize it, we burn it, it spins the turbine, and we get electricity to our grid. I know you've seen that twice already. Guess what? You're going to see it 3 or 4 more times because it's a huge concept that you have to know for this test. So how do we actually get coal? Once again, the key word here, if you only take away one thing from today's lecture, I want you to know that coal forms in swampy areas. That's the one that I see kids miss the most each year on practice tests. Coal forms in swamps. All that wetland, remember, has huge primary productivity. So when that eventually decays and dies and gets buried, you've got all that carbon being squeezed deep underneath the ground. And that's why it's nutrient rich. So what actually makes coal? Well, it's the amount of pressure and the time that it was buried. If you give it more time and more pressure, you're going to get different kinds of coal. When we have just normal decay at the surface in a swampy area, let's say the swamp dries out and it starts to decay, that's called peat. It's very organic rich. Some people would use it as topsoil in their gardens. We have a lot of peat in northern Indiana. Okay, so you can go buy peat at the hardware store, once again, to use in gardens, landscaping. Now, once it actually turns into a rock instead of kind of the loose organic material, it is called lignite. Lignite is the first kind of real form of coal that occurs. Now, the difference between these different names of coals is actually the amount of carbon in them. Anthracite is going to have the most densely packed carbon and very few impurities like sulfur in it. It all gets squeezed out. But lignite has a lot of impurities: mercury, sulfur, nitrogen. So lignite's probably only about 50% carbon. Now, if that continues to stay buried and gets squeezed, it's going to be what's called subbituminous, and that's going to have about 60% carbon, maybe even as much as 70. And the majority of the rest of it is sulfur, which once again leads to acid rain. The majority of coal that we burn in the United States is bituminous. This is the one that we have the most of. It's the cheapest. It's the easiest to get to. Unfortunately, it's still pretty dirty. It's got about 75, 80% carbon, but the rest of it is sulfur and mercury still. But it's the one we burn because of the cheap cost. Now, the one that we have the least amount of, because it forms in the deepest places, it's much harder to get to, but it's the cleanest of the coals. It's called anthracite. And if you actually see a lump of coal, anthracite is shiny. It's very near becoming a crystal, which we would then call a diamond. That's what diamonds form from. When you squeeze everything out except for the carbon and it recrystallizes, you've now created a diamond. So anthracite has 90% or more carbon in it, very little sulfur, and that's why when we burn it, it gives off more energy and less pollution. But because of its higher cost and difficult to extract, we don't use or burn very much of it. It's actually used more in industry. So this kind of summarizes what I just said. It's just on another slide for you. And we talked about BTUs, British thermal units, equivalent to a match. So if you burn a pound of lignite, it's about 7,000 matches worth of energy. By the time you get up to anthracite, we've more than doubled it. Anthracite has about 15,000 matches per pound when you burn it. You can look at the different variables here of how it forms in terms of temperature and pressure, how long it takes to form. And once again, we burn mostly bituminous. It's called low-grade coal, and the high grade is anthracite. As I just said, the bulk of what we burn is bituminous. It's used for power plants and to make steel in our furnaces in places like Gary and Pittsburgh and Cleveland. Anthracite only makes up 1%, even though it's the best. And we just simply don't have very much of it or can't get to it very easily. You might be asked on the AP exam to put them in order. Put them in order by one of those variables. Tomorrow, we're going to get into mining. And I just wanted to end today with the fact that there are over 18,500 just coal mines in the United States. We're going to look at other types of mines tomorrow as well, but almost 20,000 coal mines. And Indiana, in the southwestern part of our state, we are part of that economy. And that's one of the reasons we are a red state, because coal gives our state money. So the lobbyists are very effective at the State House. You can see that the green is where we find anthracite. Do you even see the green on the map? It's in Pennsylvania, and there's not much of it. Okay, so underneath the pressure of the Appalachian Mountains, it's been crushed and buried and formed anthracite. All right, thank you. I don't know if you found that interesting. I love this stuff. So we'll stop there today, and I'll have more jokes tomorrow, and we'll see you then.